The purpose of today's lesson is to graph and write equations for lines when we're given the slope and a point. Alright, so the first example is we have graph the line that passes through the point 2, 3 and has a slope of 1. And then we're going to write an equation of that. Okay, so they plotted the point 2, 3 and it has a slope of 1. So you go up 1 over 1, up 1 over 1. Or you can go down 1 over 1, down 1 over 1. The goal is to find your y-intercept because you already have your slope. The slope is 1. So if you have the y-intercept, you can write the equation. And that's the goal of this whole lesson. So the equation is y equals 1x plus 1 because the slope is 1 over 1. So the slope goes here and the y-intercept goes here. Okay. The next one is we have a line, I gotta pause, noise, okay, has a point negative 1, 5, so that point would be here, and a slope of 2. So we go up 2, 1, 2 over 1. Well, I get to stop right there because I have my slope and then I have my y-intercept. When you have both of those, you get to write the equation. Y equals 2x plus 5, 6, 7. 2x plus 7. You're like, whoa, this is so easy. Well, I'm sure it's going to get a little more complicated. Okay, the point is 4, 1. And the rise is down 1 over 2, down 1 over 2. I can stop right there. I have my slope, and I have my y-intercept. So the equation would be, I know I'm supposed to write it below, but this works for me. Y equals negative 1/2 x, and the y-intercept is minus 1. Okay, you got this one. So you're number 3 on your own. Okay, let's turn to the next page. How do you use a graph to write the equation of the lines above? Okay, tell me how you did that. Would it be practical to always use the graph? Why or why not? Well, no. No, when fractions are involved, it's complicated. So we don't want to have that. We don't want to have to always do that. Okay. So what I'm going to do is I'm going to show you another method that you can use instead of. You're going to use the equation y equals mx plus b. Okay? And this is how that works. So if we have through negative 1, negative 6, those are my xy, and this is the slope, obviously. Well, think of that equation, and we're going to substitute. Now, I've always used yellow for that. Well, let's say x is going to be green, and I need another color here. And that's close. We'll go light green. Light green, or that's gray, is going to be the y. And we're going to substitute the x, the y, and the m. So let's say y goes here, m is 4, x is negative 1, and we don't know, that's a b. It kind of looks like a 6. That's a b. So now we just do the math. 4 times negative 1 is negative 4 plus b equals negative 6. This is a one-step equation. This is back in 6th grade. So what we get here is we get a negative 2. So b equals negative 2. Well, now we know b is negative 2. So we can write our equation. Y equals 4x minus 2. This is one way to do it instead of trying to graph them. Okay, let's try this. This is x, this is y. Y equals mx plus b. You're going to substitute this, this, and this. You have to put all those in. Y is 4. X is negative 3. The slope is negative 2/3. All I'm doing is substituting n. So you want to sub in x, y, and m, and find your y-intercept. Okay, this is a positive. These 3's cancel, so I get 2 plus b is 4. Subtract 2, so b is 2. So the equation is y equals, use your slope, use your y-intercept, and there is your equation. Okay? The next one, we have through 4, -1, and 3/2. So x, y, m. And it helps to write the original slope-intercept form. Because then you can just see, oh, I don't want to use y, I want a -1. I don't want m, I want to use a fraction of 3/2. I don't want x, I want 4 plus b. -1, I can use a shortcut here. It's a 2. 6 plus b minus 6 minus 6, -7 equals b. So m equals -7. You've got your two pieces. Our equation is y equals -7x. Oh, kidding. That's a b. My bad. Oh, goodness. There it is. That's the slope, and it's not negative, so I'm just going to make that a really long line. And that's supposed to... Oh, boy. Making a lot of mistakes here. What's happening, brain? Okay. That's the answer. Okay. Oh, geez, Louise, that's terrible. Okay, you got number 10. All right, I'm going to do 11. We have to recognize if the slope is undefined, that would be something like 1/0. That means it is a horizontal line. Do you remember what that means? It's not horizontal. It means it's vertical. Sorry. It's a vertical line if it's undefined. And that means it's always x, and whatever the number is, that's your answer. If the slope is 0, that's when you're going to write y equals, because it's a horizontal line, and whatever y is, that's your answer. So those are nice little gifts, okay? We have a fix and justify. Let's take a look at this one. Felipe was asked to write the equation of the line that is a slope of 1/3 passes through the point 6,4. Felipe made a common error and wrote the equality like this. Describe Felipe's error and write the correct equation. It looks like Felipe just took the y coordinate and put it in for here. That's what Felipe did. You can't do that. This is x and this is y. So we have to go back to this equation, put the y here, put the x here. Not there, that's the slope. X here, the slope is 1/3, and find the y-intercept. So this becomes 2. Oh boy. So 2 equals b. So the correct equation is y equals 1/3 x plus 2. So Felipe used the y-coordinate for the y-intercept. Those are two different things. Okay? Let's see what we got going here. Write the equation of the line, show your work. You got this. Can you figure this one out? Let's see what we have here. We've got the point, because this one, we can't really get down to the y-intercept. It's not exact. So what is that? 1/3, 1/2? Is it 3/5? We don't know what this is, so we have to use algebra to solve this. So we do know for sure that the point is 3, 5. We have a point of 3, 5. What's the slope? Well, where does it intersect? It looks like it intersects here. So it's down 1, 2, 3, 4, 5, 6. That's my rise, and the run looks like it's 1, 2, 3, 4. So the slope is 6/4, or I could simplify that and it's 3/2. 1, 2, 3. Oh yeah, it's there too. I could have used that too. Either way, so we have to take our x and our y and substitute those in using our slope. And the x is 3. And we have to find b. Well, this one's not as nice because it doesn't simplify. So we have, this is going to be 9/2 plus b, because 3 times 3 is 9 over 2. And I'm just going to say this is 10/2, because 5 is the same as 10/2. So if I subtract 9/2 from 10/2, that's going to leave me with 1/2. There's my y-intercept, here's my slope. So my equation would be y equals 3/2 x plus 1/2. Ta-da! That's why you have to use algebra, because I don't know if that was 3/5. Okay, this next one, it looks like the point is 1, 1. We need a slope. Down 1, 1, 2, 3, 4. It looks like the slope is 1/4. Okay, I'm going to let you finish this one. So this one is on your own. And this is number 15. Okay. Let's see what we got here. Harper is at the bowling alley. She has spent $13 so far, playing 2 rounds of bowling. The cost for each round is $5 per person. Let X represent the number of rounds and Y the total cost. So, let's see, $5 per person. And what is the rate of change for the situation? Well, it looks like the rate of change is $5 per person. What point is addressed in the situation above? Well, it looks like, let's see, what do we have here? She has spent $13, and the point 213 represents 2 rounds of golf, or kidding, not golf, 2 rounds of bowling for $13 at a cost of $13. Okay, because she bowled 2 rounds for $13. All right, write an equation in slope-intercept form to represent the relationship between the number of rounds bowled and total cost. Okay, so obviously the slope is 5, and we're going to use the point 213. So write an equation in slope-intercept form. So just do what we've been doing. So I want you to finish 16 C and D on your own. All right, this concludes our lesson on graph and write equations from slope and a point.